Well, section 5.6. That's what we learn, the habitat rules, and that's what we're gonna use. The first thing, if we need to find, before we going on, find the limit for this one. I know you forgot how to find the limit, but first of all, we're gonna check, can we simplify this part? Can I take? Oh, that's fine. It's a positive. To find the limit for this one, what we're gonna do, can I factor the top part? Which is the same thing that x approach to the -1. And then I'm gonna say 2, and the left is x squared minus 1 divided by x plus 1. Then, can I use difference between two squares here? It's the limit for x approach to the -1, 2 x plus 1, and x minus 1 divided by x plus 1. Cancel these. Find the limit. We're gonna plug in -1 here. So -1 minus 1 is gonna be -2 times 2. So the limit is going to be what?
-4.
-4. This is just the regular way to find the limit. Simplify, then plug in the number. This is the limit, okay? The same thing here. How I'm gonna find the limit when x approaches to the infinity? Remember, we divide by the highest exponent. So we're gonna say, okay, this one is going to be the limit. When x approaches the infinity, I'm gonna divide this one by the highest exponent, which is 3x squared divided by x squared plus minus 1 divided by x squared. And the same thing here. 2x squared, you're gonna divide by x squared plus 1 divided by x squared.
2.
Yes. This one goes to the 0, this one goes to the 0. Cancel these, so the limit is going to be what? 3/2. This is the regular way. Now, indeterminate form, before we go into habitat rule, is what? To check. If I plug in -1 here, just do this in your mind. If you plug in -1 here, it's going to be 2 times -1 squared is going to be 2, right? -1 squared is going to be 1 times 2 is going to be 2 minus 2 is going to be what? 0. -1 plus 1, 0. So it's going to be 0/0. That's our goal. If the result 0/0, let's check the other one. I need to look to this intermediate form. Now, if you plug in infinity here, infinity square is going to be infinity. Any number times infinity, still infinity. -1, still infinity. So on the top, we got what? Infinity. 2 times infinity square is going to be infinity. Plus 1, so it's going to be infinity. If you got one of these cases by just looking, plug in -1 right away, plug in infinity right away, you get infinity over infinity, 0/0. That means I can use what? The habitat rules, okay? This is if you, because this is simple examples, but if you have hard examples, go ahead, check if you plug in the number. If you got one of these options, that means I can use this rule. This rule, I'm not gonna say everything here, but this rule says, if you satisfy these conditions, one of these conditions, you got one of these conditions, I can use this rule, which is the limit for f of x over g of x is gonna be exactly the same solution, the limit, if you're taking the derivative on top and the derivative on the bottom. It's going to be easier for you. And instead of taking a limit for a large equations, you can take the limit for a smaller one. And you can do it again and keep going again if you satisfy these two conditions. Okay, so now let's go back to the same examples. The same two examples. Because it says phi, we got 0/0. That means, can I use the rule? The first example, which is what? Limit x approach to the -1, 2x² minus 2 over
X plus 1.
x plus 1. So if I plug in -1 here, we get 0 on the top and we get 0 on the bottom. That means 0/0, I can use the rule. The rule says this limit is equal the same thing, the limit when x approaches to -1, take the derivative here. Is that 4x? Yes or no?
Yes.
What's the limit derivative here? 1. So now, plug in negative, can I do the same rule again? No, because plug in -1 here is going to be -4 divided by 1. So that's it. Now plug in -1, how much is the result? -4. This is the limit. Is that the same result? The same result, but because we're taking an easy example.
I see. So you can keep doing derivatives, second.
You can keep doing if you satisfy the condition. The condition is not 0/0. The condition, all these are conditions. Infinity over infinity, negative, it doesn't matter. These conditions with 0/0. Now, check the second example. If we have the limit, second example, on x approach to the infinity. 3x²
Plus 1.
over
2x squared plus 1.
2x² plus 1. Now let's do the same thing. Because we satisfied the condition, which is we got infinity over infinity. Now, can I take the rule? This one is going to be equal the limit when x approaches to the infinity. What's the derivative here?
6x.
6x. What's the derivative here? Now, the limit to the infinity. So we're going to divide by the highest exponent. That means you're going to divide this one by limit x approach to the infinity. 6x you divide by x, and 4x you're going to divide by x. Cancel these,
6/4.
6/4, which is equal.
Over 2.
It does the same thing. Because we satisfy this condition, so we can use the Habitat rule. Okay? You got it? Let's jump to the examples. You satisfy the condition. If you plug in next 6, if I plug in 6 here, it's going to be 6² minus 4 times 6 minus 12, and here 6 minus 6. On the top is that 36 minus the 24 minus 12, 6 minus 6, which is 0/0. That means I can use the rule. So now we're going to use the rule, which is the whole thing here is exactly given to the x minus to the 6, 2x minus 4, because the derivative here, and the derivative here is what? 1. Now, just go ahead and plug in the 6. The limit is going to be 12 minus 4. Yes or no? That's it. You don't have, if you go into back and use the same rule, how are we gonna find the limit without using this rule? Without using the rule. This is the second or the third section.
Open to parentheses.
We're gonna factor the top. So that's our rule. Before we say always, we're gonna simplify. We used to be factor this one, which is x minus 6, and x plus 2. Yes or no? Divide by
X minus 6.
x minus 6. Remember that? We cancel these without using the rule, just the simple way to find the limit, okay? And then you're gonna plug in the 6, so it's going to be what? 8. Is that the same result? So this is with using the Habata rule, this is without using the rule, okay? Got it? Now the next example. Oh, you forgot? How are you gonna find the limit without using the rule? That's why you're gonna say, okay, the rule is cool. How are we gonna find the limit? You have to multiply by. You forgot again. Remember when I told you every time when you see a radical, you're gonna multiply by.
Okay.
Say it, it's fine. I know it's right, just say it. Like a conjugate. Always, not the conjugate here. We need to find the conjugate on the top because the problem on the top, which is we have radical. But now, let's check, can I use the rule?
Yes.
First of all, if you plug in 0 here, it's going to be square root of 25, which is 5. 5 minus 5, 0. 0 over 0. That's mean we got 0 over 0. Can I use the rule?
Yeah.
Yes. The rule says what? This one is exactly the same thing to the x approach to the 0 to what? The derivative. I'm gonna write down this again as what? As a 25 minus x squared to the half minus 5 divided by x. Go ahead, find the derivative for the top, which is equal what? Half 25 minus x squared to the negative half.
Times 2.
The derivative for inside, which is negative 2x. Minus the derivative for the 5 is what? The derivative of x is what? You see, you don't have to think about conjugate, whatever, just find the derivative. And now, go ahead, write down this again. It's going to be equal, the limit. For x approach to the 0, is going to be cancel the 2 with the 2. So the left is negative x over square root of 25 minus x squared. Yes or no? Now go ahead and plug in. How much is going to be the result?
0.
0 over 5, which is?
0.
0 over 5 is, don't say that again. Going to be negative 0, which is 0 over 25 minus 0 squared. So it's going to be, here is 0 over 5, which is equal. You got it? You got it? It's easier now to multiply by conjugate and then simplify. How are we gonna find the limit? How are we gonna find the limit if it's without using the rule?
Divide by the highest exponent.
It's not to the infinity. You can divide by the highest exponents only if you have infinity. So with this one, you have to simplify. You have to factor this one, and you have to factor this one. How are you gonna factor this one? It's x to the power 7. It's not x squared. It's x to the power 7, and we have x to the power 23. You have to write down, I'm gonna write down here, that x to the power 7 plus 0 x to the power 6 plus 0 x to the power 5, keep going. Until the last one is minus 1. How are we gonna factor this one? Just trying to refresh your memory. You remember what? Little bit. And how are you gonna factor this one? You're gonna find the P, and then you're gonna find the Q, and then you're gonna find the possible zeros, and then you're gonna use what? Synthetic division. See how it's long the steps? To factor this one, I'm not finding the limit. Factor in this one, x to the power 7. What about x to the power 23? It's gonna be really super long, right? So now, the first thing, always think about using this rule. If you plug in 1 here, you 1 minus 1, 0. Plug in 1 here, 1 minus 1 is going to be what? 0. So 0 over 0, that means I can use the rule. What's the derivative for the top?
7x to the 6.
7x to the power 6. Here,
3x.
to the power 22. Then you're gonna plug in the limit. So how much is gonna be the result?
7 over.
See, the important for this rule. How much time you gonna save?
So much.
What about this one? How are you gonna find the limit? You plug in 0 here. What's sign to the 0? The sine over cosine? Who has the problem, the examples? Do you have the examples? No? Just want to make sure, it's 5x. Oh, it's sine, yes. That's what I'm saying, because with this example, we can't use the rule. Because if I plug in 0 here, it's going to be sine 0, which is 0. If I plug in 0 here is 1. 0 divided by 1 is 0. That means I can't use the rule. I have to get 0 over 0. 0 from the top and 0 from the bottom. Okay, so I can use the rule. That's why I'm saying there's something wrong with this one. It's sine over sine. Over sine, let's say 5x. Now, if you plug in 0, it's going to be 0 on the top and 0 on the bottom. That means I can use the rule. So this one is equal the limit. When x approaches 0, what's the sign for 2x? The derivative.
It's cosine
It's cosine 2x
times 2.
times 2 times the derivative of the angle. So it's cosine 2x times 2. And here is going to be cosine 5x times 5. You can write it down as a limit, x approaches to 0, 2 cosine 2x over 5 cosine 2x. Now, if you plug in the 0, cosine 0 is going to be 1. Cosine 0 is going to be 1. So the result is going to be what? You got it? Limit to the infinity, we're going to divide by highest exponents. And then we're going to plug in the infinity. Now we need to use the rule. If I plug in infinity here, 4 times infinity is going to be infinity. And everything on the top is going to be what? Infinity. The same thing on the bottom. If you plug in infinity, so we got infinity over infinity. That means I can use the rule. The rule says it's the same thing. The limit when x approaches to the 0, sorry, to infinity. What's the derivative here? Plus 7. Derivative here.
6x.
That was the next step. So we use the rule from here to here. Now, we need to find the limit to the infinity. That's mean I'm going to divide by the highest exponent. But now I'm gonna look, if I plug in infinity here, 8 times infinity, infinity plus 7 also is going to be infinity. 6 times infinity. So can I use the rule again? It's right when you find the limit here by dividing by the highest exponent. It's exactly the same number, but I'm checking the rule. Can I use the rule again? Yes, I can use the rule again because I got infinity over infinity. Now that's mean this one equal, what's the derivative here?
8. 6.
Going to be 8 from the top, and here's going to be what?
6.
6. So what's the result?
6.
8 over 6. Even if from here, if you divide by the highest exponent, you're gonna get 8 over 6. You got it? We? Because we have to divide by the highest exponents and divide by what? X over 4? It'll be super hard. Can I use the rule? So if you plug in infinity here, it's going to be infinity. What about if I plug in infinity here? It's be infinity. Infinity divided by 4 is still infinity. The exponential to the infinity, to the negative infinity is gonna go to the 0. But to the positive infinity is gonna go to the infinity. That's mean the whole thing here is infinity. So that's mean we got infinity over infinity. So I can use the rule. Equal. Here is the limit. X approach to the infinity. What's the derivative here? 3x squared. What's the derivative here? So here is the 5.
Stays the same.
But
Times X over 4.
times the derivative of x over 4, right? Because the derivative of exponential function e to the x equal the same function times the derivative of the exponents. Okay, so now it's gonna be still the same, which is x over 4 times what's the derivative of the exponent? The derivative of x over 4. Come on, what's the derivative of x over 4? It's a quotient, okay. 4 times 1 minus x times 0, right? Over 4 squared. Using the quotient rule, this is 0, so it's gonna be 4 over 16, which is. That's mean here is going to be 1, 4. So this one is equal, the limit, when x approach to the infinity, from the top, 3x squared, and here is what? It's going to be 5 over 4 e to the x over 4. That was cool, that. Now, can I use the rule again? This is infinity. This one is still infinity. This number times infinity, infinity. So that's mean. Satisfy the condition. So I can use the rule again. So this part is going to be equal. The limit when x approaches to the infinity. The derivative of the top is what?
6x.
The derivative here is going to be this number, the same function times what? 1 over 4 again. That means this one equal. The limit when x approaches to the infinity, 6x over 5 over 16 e to the x over 4. Now what's the next step?
You could take it again.
Can we? Yes, we can. We're gonna keep going, but what's gonna happen?
Be 6 over 5
It's gonna be 6 over what?
5 over 64.
Do the derivative again. limit x approaches to infinity is going to be 6/5/64 e to the x over 4. Now what's the next step? You got it or you lost? You got it?
So it's 6x/5/4 e to the x.
Because I'm gonna, okay,
But
Good.
wouldn't it already be 6 on the side?
wait. Think about this one.
That's over here.
On this one, I'm going to find the derivative again of this part. So 5/16,
Oh, I see,
you
okay.
got it?
Yeah, I got it.
I know you're lost.
Yeah, sorry.
5/16 times 1/4 equal, so the limit x approaches to the infinity will be 6/5/64 e to the x over 4. Can I do the rule again? No,
Get 0.
because you're gonna get 0 here, and here you're gonna get infinity, so I can't do the rule again. But now go ahead and plug in. If you plug in this one, infinity divided by 4, everything here is going to goes where? To infinity, okay? Now, any number times infinity, infinity, that's mean 6/infinity is what? No, don't say that. Perfect. So 1/x. 1/x. Remember this function? So when x goes to the infinity, the function goes where? 1/x.
Zero.
If the x going to infinity is going to be like 1/infinity, the function is going to be equal 0. The same thing here. We have 6/x, and x going where? To infinity. So 6/infinity is going to what? You got it? It's okay.